Hey guys, our homework for 11.1 is 10 through 31, skipping around a few here and there. Okay, so let's start. 10 says a mathematical connection if you rotate the rectangle about CD. So if you spin this, you'll get this like circular surface on the top, and down here on the bottom, you're going to get a circular surface. And notice this is starting to look like a cylinder. So we get a cylinder because when we spin the top, we get a circle on the top, and we spin the bottom, we get a circle on the bottom. What is the volume? So when I spin this, this is 12. So then this turns into, all the way across would be 24. But the radius of my cylinder is 12. And this is my rectangle, right? So that's 5. So you could Google this. We are going to get into this. The area of a cylinder is the area of the base, which is pi r squared, times however high you stack those circles. So that's our height. So that would be pi times 12 times 12 times 5, or 144 times 5 times pi. That's what I get. If they asked for it, and that'd be centimeters cubed. If they asked for it as a decimal, 720 times pi, I get 2261.9. Cool. Let me double check my work there though. 144 times 5 is 720. Yeah, 720 pi. Question number 12. A tetrahedron, so only triangles, is a polyhedron with 4 right triangular faces. So the face on the bottom and then the 3 triangles on the side. Can a plane intersect the tetrahedron shown to show something with 4 sides? I think, yeah, you could pick these front 2 and the bottom 2. We could find 2 points here and 2 points here, and then just connect those. And I think we would get, we can find 4 points. And connect them. To make a cross, I cannot write, to make a cross section with 4 sides. Okay, number 13, it says, can you intersect a plane in a triangular prism to produce a rectangular cross section? Yeah, I can pick these 4 points. And this is going to make a rectangle. So a prism prisms have rectangular faces. So anything parallel to a face you're going to get a rectangle. And it says draw a diagram to explain. And that's exactly what we did. So we see this would be our plane that's intersecting, and we can kind of use, oh, a little too big there for me. Kind of use a highlighter to kind of show this plane intersecting. Cool. 14. Is it possible to rotate a polygon to form a cube? We said in class no, because rotation creates circles, and polygon has no circular faces. Okay, good questions. Now we look at question number 20. It says draw a cross section. Oh boy, a lot going on there. It looks like not a double cone, but a double pentagonal pyramid. Draw the cross-section formed by the intersection of a plane and the polyhedron shown. What type of polygon is the cross-section? So it looks like we have 2 points on top. Wait, we're going to count the points. So they match here and here, here, here. So 3 on this side, and there's going to be an invisible one on that side. So I'm going to say a hexagon, and I'm going to draw it. This is kind of popping out. Something like this would be the cross-section. 6-sided. Neato. All right, 21. Visualize the plane intersecting a square pyramid parallel to the base. So anything parallel to the base, we can connect these, is going to get the base again. So parallel to the base gives you the base. So our base is a square, so we get a square. Describe the cross-section, we get a square cross-section. 22, visualize a plane intersecting a square pyramid through the vertex and the perpendicular to the opposite edges of the base. All right, so we're going to draw our pyramid just like they drew a pyramid. All right, redraw a pyramid. A plane that's perpendicular to the opposite edges of the base. Okay, so I guess this would be perpendicular to the opposite edge. So a plane that's here, right? Perpendicular to the opposite edges. This cross-section is a triangle. So we get a triangle cross-section. Again, anything perpendicular to the base in a pyramid is going to get triangles. Why? Because pyramids have triangular faces. So perpendicular base, you're going to get the face. 24, describe the 3D figure that is formed by rotating. Oh, this is cool. Okay, so rotating this, I'm going to get a cone on the top. So it's kind of going to look like a barn on the top. And then on here is a cylinder. So it's like you took a cone, and you set it on top of a tin can. What figure that is formed by rotating a pentagon about a line shown? So it looks like I get a cone and a cylinder, which makes sense because a pentagon on one side is a triangle, and a triangle makes a cone, and this is a rectangle, and a rectangle makes a cylinder. So I should get the combination of a cone and a cylinder. Describe the 3D figure formed by, okay, so we kind of, yeah, we talked about that. This I'm getting, like rotate this, I'm getting what looks like a planet. We also call this a sphere. Sphere. Spinning a circle makes a sphere. Right out of our notes. Okay, 28, it says, Rebecca wants to install a safety mat under the path of a revolving door. So some kind of safety mat here. But not after you get out of the revolving door. They want to install it inside of it. So inside of here, they want to install a safety mat. What shape should she make the mat? Well, notice we can see the top really well, and this revolving door is a big cylinder. So what's the shape of the mat? the shape of the mat is a circle because it's the bottom of a cylinder. So if we sketch this, this is the area of our mat, and that's a circle. Cool. Okay, two more. Now these are like you might see on the SAT, ACT, you know, how would things look, or on our EOC. Select all true statements regarding rotating 2D shapes. Okay, so we definitely explored this. A circle would make a cylinder. No, a circle makes a sphere. So that's a big no. An isosceles triangle rotated about its height forms a cone. Yes, we discovered that one in class, so that's a big yes. A rectangle rotated about its edge forms a cylinder. Yep, we had some folks in class that did that one. Big yes. A circle rotated about its diameter forms a sphere. Yes, okay. And a right triangle rotated about its hypotenuse. Ooh. This was on our lesson check, right? If I rotate a triangle, I'm going to get this double cone. Right triangle rotated about the hypotenuse forms a square. But no, indeed, a pyramid has no circular faces. So you can't spin stuff and get something without circle faces. So this one is a big no. To correct it, you would get a double cone. Cool. Way cool. Question number 30. What best describes the cross-section of plane X and the polyhedron shown? All right, so it looks like it's parallel to a face. So we're just getting more pentagons. Thanks for joining us, guys. Take care.